See sir, solutions continuing. The last lecture is the lecture number 2 for solutions. First here, the term strength. Strength, sir. So strength means what, sir? Strength means the mass of solute in per liter solution, sir. This is called as strength, sir. The mass of solute present in per liter solution, sir. See, in the form of formula, sir, mass is nothing but weight, volume in liters, volume in liters. See, some molarity means what, sir? This is also one concentration term, sir, right? Weight by molecular weight into volume in liters. Volume in liters. See sir, observe carefully. Here weight by volume in liters, here weight by volume in liters. So molarity is equal to strength by molecular mass. Strength is equal to molarity is equal to strength into molecular mass. Alright, sir. See, strength is equal to molarity into molecular mass. And one more formula is there here. Observe carefully. Weight by volume percentage. See, weight by volume percentage means weight of solute W, that is in grams, right? Volume in liters, volume in ml into 100 into 100. So strength means, see sir, again, right? Strength is equal to weight in grams by volume in ml, right, into thousands, thousand. See, so weight by volume is equal to weight by volume in ml into 100, sir. Right. Strength is equal to what, sir? Weight by in grams, volume in ml into 1000, sir. Just you have to write here weight by volume percentage into 10, sir. Sir, I did not do anything, sir, here. Just this formula I kept over there, right? This is about the strength, sir. Here one more term is standard solution, sir. Standard solution. See, standard solution means what, sir? Standard solution is nothing but just the known concentration of solution, sir. See, the known concentration means what, sir? The solution concentration is known. That is called as standard solution, sir. That's all, sir, right? The next term is temperature dependent, that is normality, sir. Normality, sir. See, normality means what, sir? Normality means the number of equivalents of solute present in per liter solutions. So generally normality used in titrations in laboratory, sir. In laboratory, right? See, sir, here the number of equivalents of solute present in per liter solution, sir. So here new term introduced, that is equivalent, sir. Equivalent. See, sir, equivalent means what, sir? Sir, equivalent means the definition of equivalence. Here, observe carefully, my dear students. Right? Equivalence means the mass of particular substance that can combine or that can combine 1 gram of hydrogen, sir. 1 gram of hydrogen, sir. Or it replaces 1 gram of hydrogen, sir. Or 8 grams of oxygen, sir. See, sir, once again equivalent definition. The mass of particular substance that can combines 1 gram of hydrogen or it replaces 1 gram of hydrogen, sir. Or 8 grams of oxygen, sir. So this is the definition of equivalence, sir. So formula, according to formula, right? Here the equivalence means weight by equivalent mass, sir. Weight by equivalent mass. Sir, here again one term introduced, that is equivalent mass. So what is this, sir? So equivalent mass is nothing but, see, sir, observe carefully, equivalent mass is molecular mass by n factor, sir. Sir, this is n factor, this is the big factor, sir, in this normality, so be careful, sir, right? See, sir, right. Next, actually the normality according to mathematical formula, right? Here normality is equal to, right, number of equivalents by volume in liters. So equivalence means what, sir? Equivalence means weight by equivalent mass. So put here, sir, equivalent weight by equivalent mass into volume in liters. Sir, equivalent mass means what, sir? Equivalent mass means molecular mass by n factor, sir. Put over this formula right here, over there, weight by molecular mass into n factor, sir. N factor by volume in liters. So final formula, what's the final formula? Normality is equal to, that is denoted by capital N, sir, I forgot, right? Capital N, right? Weight by equivalent mass into n factor by volume in liters, sir. This is the final formula, sir. Right, sir. Once again I repeat, see, sir, first of all, equivalence means what, sir? Equivalence means according to mathematical formula, right? Equivalence means weight by equivalent mass, sir. So this is the equivalent mass means also new term, sir. This is also new term. So equivalent mass means what, sir? The molecular mass by n factor, sir. So molecular mass means what, sir? That is the solute molecular mass, sir. So actually the normality is equal to equivalent mass by volume in liters, sir. Number of equivalents of solute by volume in liters, sir. So equivalence is equal to weight by equivalent mass, sir. So just I put here, sir, weight by equivalent mass into volume in liters, sir. So equivalent mass means what, sir? Molecular mass by n factor, sir. Here n factor is in downwards, sir, denominator, so it will be go up, means that is in numerator, sir. So final formula is what, sir? N is equal to weight by equivalent mass into n factor by volume in liters, sir. So this is about the normality, sir. So here the n factor is very big factor, sir. We have to calculate, sir, for acids, for bases, for salts, for reducing agents or oxidizing agents, sir. So stay tuned, right? So please take down, right? See, calculation of n factor, sir. Calculation of n factor, sir. N n factors. N factor. Calculation of n factors. C for acids. For acids. See, sir, number of H plus ions given by acid. So this is the n factor, sir, for acids. For acids. See, number of H plus ions given by acids. Sir. Examples, sir. Example, taking example, CH3COOH gives rise to CH3COO minus plus H plus. So this is acetic acid, right? It gives one H plus ion. So what is n factor, sir? N factor is 1, sir. N factor is 1. Right, so this is a weak acid, sir. This is a weak acid. Now, next strong acid. See HCl, sir. HCl, right. See H plus plus Cl minus, sir. See how many you are giving, sir? Only one hydrogen giving, sir. So that is the reason n factor is 1, sir. See for H2SO4, sir, H2SO4 is strong acid, sir. Right here 2H plus plus SO4 minus 2, sir. So minus 2. So 2 hydrogens, 2 H plus are giving, sir. So that is the reason n factor is 2, sir. That's all, right? 2, sir. See here the again H2SO4 giving here the possibility is only for 1 H plus, 1 H plus HSO4 minus, sir. So what is the n factor, sir, here? 1, sir. Why? Because n factor is depends upon the chemical reaction, sir. Chemical reaction, that's all, sir. Please remember, right? N factor is depends upon the chemical reaction. See, in this case, what happens? 2 hydrogen, 2 H plus are given. In this sir, in this what happens? Here 1 H plus given, sir. That's all, sir. It depends upon the n factor is depends upon the only chemical reactions. For this is acid, sir. Right, sir. So please take down, right? For this is about acids. It's about acids. So one more example. See H3PO4, sir. H3PO4. So phosphoric acid, sir. This is phosphoric acid, right? See 3H plus plus PO4 minus 3, sir. Sir, here how many H plus are giving, sir? This is acid. This is acid giving 3 H plus. So that is the n factor is 3, sir. That's all, right? See, sir. So for base, next is for base, sir. Base. Calculation of for base. So what is means of base? See, first of all, number of OH minus ions given by base. That's all, sir. See, number of OH minus ions given by base. It is a very easy, sir. Right? Number of OH minus ions given by base. See, example, sir. Example. See, NaOH is a base. Right? It gives Na plus plus OH minus. Sir, here how many OH minus is giving, sir? Only one OH minus is giving, sir. So that is the reason. What is the n factor, sir? N factor is equal to 1, sir. That's all. Right? See, sir. Next example. CaOH taken twice, sir. Right. Here Ca plus 2 plus 2 OH minus, sir. 2 OH minus. See what it means, sir. 2 OH minus giving means what is n factor, sir? Just n factor is 2, sir. That's all. N factor is 2, sir. Right. Next for acids. Next for salts, sir. Next for salts. Calculation of n factor for salts. Salts. So salt means what, sir? Salts means cation and anion, right? It will be present in that. See, total magnitude of charge on cation. Charge on cation. So cation means what, sir? Cation means positive charge ion, sir. That's all, sir. Right, total magnitude of charge on cation, sir. Examples is, sir. Example, CaSO4. C, sir. Ca plus 2 plus SO4 minus 2, sir. So what is the N factor, sir? The N factor is 2, sir. Why? Because the total charge on the cation, sir. The total charge on the cation, sir. So that is N factor is 2, sir. CuSO4, sir. Right, sir. In this case, Cu plus 2 plus SO4 minus 2, sir. See, total charge on the cation. So what is the total charge of cation? Plus 2, sir. That's all. So N factor is 2, sir. That's all. Next, sir, NaCl, sir. The best example is NaCl, best salts. So salt, this NaCl is salt, right? Here, Na plus plus, Cl minus, sir. So what is the charge of the sodium plus, sir? Plus 1, sir. So that is the reason, right? N factor is equal to what, sir? 1, sir. So this is about for salts, sir. This is about for salts. Next, for N factor, oxidizing agent and reducing agent, sir. Oxidizing agent for oxidizing agent, reducing agent, sir. Reducing agent. Reducing agent, sir. See, the best example is KMnO4, sir, right? KMnO4. So this is in acidic medium. Sorry, sir, before that. So transfer of electrons, sir. Transfer of electrons. That is N factor for oxidizing agents and reducing agents, sir. See, sir, carefully, observe carefully, sir. Right here over there, just KMnO4, sir. Right. See, in that KMnO4, in acidic medium, sir. In acidic medium, H plus means acidic medium, sir. Right. Here, Mn plus 2. Sir, here what is the oxidation state of Mn, sir? Here plus 7, sir, plus 7. See how it will come the plus 7. Just look at the board, sir. I will explain you. Sir, we don't know this is first, right? We consider as X, right? So here one oxygen is minus 2, sir, valency, right? Here minus 2, right? Here 4 oxygens are there, sir. So 4 there, sir, right? Right, here potassium valence is 1, sir. Keep here 1. Right, here only 1 there, sir. That is the reason put 1, sir. As it is plus is equal to 0, sir. So why it is 0, sir? The total charge of the KMnO4 is 0, sir. So X is equal to minus into 4, that is minus 8. It goes upside, that side means that is plus 8, sir. That is plus 8. So this is plus 1, sir. Go that side means minus 1, sir. So what happens, sir? Plus 7. So X is equal to plus 7. This is the oxidation number, sir. This is oxidation number, sir. This is oxidation number, sir. See once again. See, first of all, Mn we don't know, sir. So that is the reason we consider as X, right? So after that, see, one oxygen is minus 2, sir. So minus 2 I put over there, right? See, 4 oxygens there, sir. So that is the reason I kept here 4, right? Here potassium valency is 1, sir. Valence is 1. So kept I 1. Here how many are there, sir? 1 there, sir. So that is the reason 1, sir. 1 into 1, 1 plus X plus minus 2 into 4, minus 8. Right, so minus 8. So minus 8 go that side means plus 8. This plus 1 go that side means what happens, sir? Minus 1. So totally plus 7, sir. So that is the reason this is a plus 7, sir. Plus 7. See, sir, plus 7 2 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 plus 2, sir. This is called as reduction, sir. This is called as reduction. So reduction. So reduction definition, see sir, the gaining of electrons is called as reduction, sir. See, generally, for our convenience sake, just I'm saying one example, sir. See, one electron is nothing but -1, sir. For understand beneficials, I consider as one electron is equal to -1, sir. So remember, please, right here the +7 there, sir. Here +7 there. So +7 to +2 means what happens, sir? What happens, sir? Here happen 5 electrons are gained, sir. Here 5 electrons are gained, sir. Why? Because one electron I consider as -1, right? -1. So 5 electrons gain means what, sir? 5 electrons gain means -5, sir. +7 -5. So what happens, sir? Here +2, sir. +2. So here to here, what happens, sir? 5 electrons are gained, sir. 5 electrons are gained. So this is called as what, sir? Reduction, sir. Reduction. The gaining of electrons is called as reduction, sir. So what is the n factor, sir? 5, sir. What is the n factor? The transfer of electrons. So that is, how many electrons are transferred, sir? Here 5 electrons are transferred, sir. 5 electrons are transferred for MnO4, sir. So +7 comes to +2, sir. So this is about in acidic medium, sir. This is about in acidic medium. Sir, what about in basic medium, sir? What about in basic medium? See, in basic medium, KMnO4, right? In basic medium means, sir, OH minus, right? K2MnO4, sir. Sir, here K2, how it will come, sir? Here KOH, sir, right? That's all. KOH is base, sir, base. It is base, sir, right? If it is over there, takes over there, K2MnO4, sir. Sir, this is +7, sir. Why? Because just now we have seen, we calculated over there, right? But here observe carefully, sir, right? We don't know this manganese, right? So that is the reason we put here X, sir. So plus as usual, right? Here one oxygen is -2, sir. Valence is -2. So keep here -2, sir. And here how many are there? 4 there, sir. So that is the reason, keep over there 4, sir. Plus as usual, sir, here valency of the potassium is 1, sir. Why? Because the sodium, potassium, rubidium, cesium, francium, these are all first year group elements, sir. So that is the reason in every case that is only 1, sir. That's all, right? 1. So here 2 there, sir. 2 there. So that is the reason if you put here over the 2, sir, right? The total charge of the KMnO4 is what, sir? 0, sir. So that is the reason 0, sir, right? See, X is equal to -2, 4, sir. What happens, sir? -2, 4, that is +8, sir. If go that side means, right? This is +2, sir. That goes that side means what happens? -2, sir. That's all, right? X is equal to what, sir? +6. +6. See, sir, +7 to +6 comes, sir. So +7 to +6 has come, sir. So means what means that, sir? That means it gains 1 electron, sir. It gains 1 electron. So it gains 1 electron, right? So that is the means it gains 1 electron. So that is the reason +6 comes, sir. So 1 electron I consider as -1. So if it gains 1 electron, what happens, sir? +6, sir. +6. +6, sir. See, this process is called as what, sir? Reduction, sir. Reduction. So why it is reduction, sir? The electron gain, sir. Electron gain. The manganese electron gain, sir. So this is called as what, sir? Oxidizing agent, sir. This is called as oxidizing agent. Which one is gaining the electron? That is called as oxidizing agent, sir. That's all, right? See, n factor is what, sir? 1, sir. Why? Because 1 electron is transferred, sir. 1 electron is transferred. Sir, 1 electron transferred. That's all, sir. That's all, right? Next, in basic medium, sir. Sorry, it is basic medium is finished. Right? Next, acidic medium, sir. Sorry, acidic medium also finished. Right? Neutral medium, sir. Neutral medium. Neutral medium, sir. So what happens, sir? MnO2, sir. MnO2, sir. See, here +7 we calculated, sir, right? Already calculated. Sir, MnO2, sir. MnO2. Sir, this is X, right? Plus as usual, keep plus as usual. One oxygen is -2, sir. -2, that is 2 is equal to 0, sir. So X is equal to what, sir? +4, sir. That's all. So what happens? Plus 7 to plus 4, sir. So what happens? Plus 7 to plus 4 means 3 electrons are gained, sir. Why? Because 1 electron is equal to minus 1, sir. If 1 electron gained, what happens? Plus 6. Sorry, sir. Plus 5. If 3 electrons are gained means plus 4, sir. See, sir, once again I repeat. Here 1 electron means minus 1. I consider, sir. Right? So that is the reason you have to remember, for our beneficials, for our convenience sake, I have considered like that. 1 electron is equal to minus 1. See, sir, plus 7 is there, sir, here. Right? If gains 1 electron, plus 6 will come, sir. If gains 3 electrons, plus 4 will come, sir. Right? So this is about reduction, sir. This is about reduction, sir. So this is about reduction. So how many electrons transferred, sir, here? 3 electrons are transferred, sir. 3 electrons transferred. 3 electrons transferred. So that is the reason n factor is 3, sir. 3, sir. Now, see, sir, equivalent mass of KMnO4 equivalent mass of KMnO4 in acidic medium, molecular mass of KMnO4 by 5, sir. Why? Because 5 electrons are gained, sir. Equivalent mass of KMnO4 in basic medium, sir. Basic medium, right? Molecular mass by 1, sir. 1. This is about in basic medium, sir. Equivalent mass of KMnO4 neutral medium, sir. Molecular mass of KMnO4 by 3, sir. This is about acidic medium, sir. This is about basic medium, sir. This is about neutral medium, sir. Neutral medium, sir. So this is about the n factor calculation, sir. I hope you clear. You don't worry, my dear students. If you not understand, once go back and see again and see again. Spend the time, sir, on studies. You will be get everything, sir. Right? Please spend the time, sir. Right? So your final term, relation between molarity and normality, sir. Molarity and normality, sir. So normality means what, sir? Equivalent volume in liters. Weight by molecular weight into n factor by volume in liters. So molarity means what, sir? Molarity means weight by molecular weight into 1 by volume in liters. Volume in liters. So here observe carefully. These term and these terms are both are same, sir. Both are same. So that is the reason. If you in this place you have to replace just molarity, sir. Right? That is n is equal to molarity into n factors, sir. N factors. So this is the lecture number 2. That's all, sir. Please spend on the time on studies, sir. You will be get anything, sir. Right, sir? Thanks a lot.